In this tutorial, we're going to show you how to use the Auto Inlay Toolpath feature. This allows you to compensate for the tool radius when cutting parts that you want to insert into another piece. In our example, we will take the male letter E on the left and attempt to insert it into the female pocket on the right. This would not easily be possible with the standard profile and pocket toolpaths, as they don't make allowances for the fact that the tool cannot create an internal sharp corner. The Auto Inlay Toolpath guide takes into account the tool radius, rounding off the corners and allowing you to have two shapes that will slot together without any problems. Okay, so we'll first close this part down, and then we're going to create a new file, and in this case it will be a single-sided job, width 10, height 6, and our thickness will be just ½ inch. Our Z0 will be from the material surface, and our XY datum will be in the lower left hand corner. So we now have our new part and we can proceed to create some letters. So with this, I'll move across to the draw text command, and we'll open this up now, and we're going to create a height of 4 inches, which is already specified. I'm just going to pick the location since we're going to create two. So I need to create one on the left first, and we're going to be using the Arial size, and I'm just going to type in the letter E, and we're going to have this as bold. Okay, so with this, I'm just going to close this form down. I'm happy that I have the correct letter on the left hand side, but of course I need to copy it across to the right hand side. So I'll select the letter, which will put it into transform mode. I'm going to hold the Control and Alt key on the keyboard, hover over the middle and just move this across, and you can see that it's keeping it in line in X, so the two will be side by side, and that's by holding the Control for the copy and Alt to keep it orthogonal. Okay, so I'm just going to locate that now, and I can proceed now to move across to the toolpathing functions, where we'll take a look at the toolpathing of these two letters. So in order to highlight the issue, we're first going to take a look at using the existing profile and pocket toolpaths and take a look at the issues faced as a result. So the first thing we need to do is to come across and set up our material. So we're using ½ inch material. Our XY datum is in the lower left hand corner. Our Z0 will be from the top of the block, and I'm happy with our rapid and home start positions. So I'm going to move down now and select the left hand letter, okay, which is actually going to be our male, and move across to the profile toolpath. Now our start depth will be 0, we'll be cutting straight from the top of the material, but our cut depth will need to be the material thickness. In this case, we'll be going all the way through. If I don't know what that is, I can just type in Z equals on the keyboard, and that will give me the material thickness. Our tool, we will select a 1/4 inch end mill for this process. And we're going to come down now to where we say machine vectors, whether we're going to go outside, inside or on. In this case, we will go outside since we're machining the male, therefore we're cutting the outside of the profile. And then I'm just going to come down and I'm going to call this just male, okay, and we're going to call this profile as well. So we're going to create the male component using the profile toolpath. So I'm going to calculate that now, and immediately you can see the toolpath created, and I'm just going to use the preview just to play that so we can see the cutout and the resultant letter that will be created as a result of using the profile toolpath and the 1/4 inch end mill. Okay, so now we're going to come back and just tile this view now into horizontal so we can see the 2D and 3D together. And I'm going to come up and select the right hand letter now, which will be essentially the pocket into which we want to insert the male into. So I'm going to close out of the preview now and come up to the pocket toolpath. And our cut depth, once again, the start is 0 from the top of the block, and our cut depth is not the full thickness. We're just going to go down by half the material thickness, so essentially the letter sits slightly proud in the pocket, and that will be just 0.25 of an inch. We need to use the same tool, so we're going to use the 1/4 inch end mill in this case. And I'm now going to decide on the strategy, whether we want to use offset or raster. In this case, I'll use offset, bearing in mind the shape that we've got of the letter. And then I can just come down and just type in female. And this will be using the pocket toolpath. Okay, so I'm going to calculate that, which will produce the toolpath we see at the bottom of the screen. And I'm just going to preview that now. And we can see that pocket created. I'm just going to color in the actual preview there so we can see exactly what we are faced with. So we can see that we have the male letter on the left and the female pocket on the right. Okay, in order to take a closer look at the issues, I'm going to switch on both the toolpaths and make sure that we're showing the 2D toolpath as solid so we can see the actual area the toolpath is cutting. Now, if we actually zoom in to the 2D view, we can clearly see the toolpath profile shown in blue, and we can see the resultant area in white, which is actually the letter that is left as a result of the toolpath. And we can see here in the internal corner, the tool cannot cut the sharp corner, therefore is leaving a radius in that corner. So that's on the internal radius on the male E. Now, if we come across to the female, okay, and of course the tool can easily pass round the outside. That is an external corner there. It can create the sharp corner, but of course we have a mismatch between the shape created on the male form to that created on the female form. And if we highlight this again, for instance, with the female, we have the internal area where it's trying to round the end of the letter E here. You can see that it's not able to create the sharp corner. As a result, the tool will leave an amount of material in that corner. And if we come across to the male letter E, where we're going around this external corner, of course the tool can easily pass round. It can create that sharp corner. So essentially we have a mismatch between the male E, which has a nice sharp edge, to the female E, which has a rounded internal corner. Therefore there will be a complete mismatch. So it's not as straightforward just to pick two letters and cut one with a profile, one with a pocket, and hope it all fits together. We need to use a different strategy, which is to use the Inlay Toolpath. So with this, I'm actually going to delete out the two toolpaths, and then we're going to go ahead and create the same process, but using this neat toolpath. So I'm just going to delete out the two different toolpaths. So I'm just going to delete all of these. Okay, and then we're just going to reset the preview, and then we're going to come back to the 2D view, have that full screen, and now look to create the toolpaths using the Inlay Toolpath feature. Okay, so we have the vector for the male letter selected on the left hand side, and we're going to come across to the toolpath menu, but not select our profile toolpath, but move across and select essentially our Inlay Toolpath feature. So this opens the form, and we have a few different options for the type of inlay that we want to create. We're going to start by creating essentially a straight through, so a direct cut through the material for the male letter, which will sit into a pocket for the female. And then following that, we'll look at the sort of a stepped format where the letter pushes in from the back of the hole in the female. So we're going to go straight through and select the straight option first, and immediately we've got a form that looks a little similar to the profile toolpath that we've been looking at before. We've got our start depth and cut depth, and that's already set to the material thickness, which is 1/2 inch. And we're going to come down and select our tool. In this case, we want to use the 1/4 inch end mill, which we'll select, and we don't need to select any other options other than obviously the direction of travel, which in this case is going to be climb. I'm now going to move down, directly down, and just change the name of the toolpath. So we're going to call this male inlay. So I'm just going to remove the one on the end there and calculate that now, and we can see that toolpath generated, which I will preview. Okay, and we can already see that there is some level of compensation that has been done. We can see that we have rounded off the external corners on our letter in preparation for the fact that we cannot generate the sharp corner on the female. Okay, so we're going to pop back now to the 2D view and just do the same for the female. So I'm going to select the letter on the right hand side and just come across now, open up the Inlay Toolpath again, and we're going to come down to the female section here and select the pocket option. And our start depth once again is 0. Our cut depth is not all the way through. We're just creating a pocket. So this will be half the material thickness, which is 1/4 inch. Our tool needs to be the same here. So we need to use the same tool for both the female and the male. Okay, in this case, it will be the 1/4 inch end mill. Okay, and then we're going to come down now and just select the strategy that we want to use. I want to use offset strategy again here, and in this case rather than the being the male, this is going to be, I'm going to call this the female. Okay, so there'll be the female inlay. Okay, and we'll just then generate that toolpath, and we can see the toolpath generated in the 3D view. I'm now going to preview that now, and we'll just change the color, and once again just to show this in red so we can see the two there. Now immediately you can see there appears to be a very good match. Okay, there's allowances that have been made both on the female side and the male side. If we take a look at the male here, we can see that we've rounded the top left hand edge and also at the end of the letter here, and that matches in with the internal radius generated in the female in the same two locations. Similarly, in this area here where the tool was going round the inside of the female, we were able to originally generate a sharp corner there, but that's being purposely rounded off because we cannot generate the same sharp corner on the male. So the two have been matched. Both sets of vectors have been modified. Now if we show this in the horizontally tiled view and switch on the two toolpaths, and in particular zoom in now, we can see the allowances have been made. In particularly in the male version here, we've rounded off that corner on the top left and also at the end of the letters here. You can see in these three regions. And if we come across to the female, once again you can see that it's created an internal radius here. Okay, whereas normally it would have been able to create a sharp corner there, it's naturally created the rounded shape to match the rounded shape that can only be generated by the tool because it cannot generate the sharp internal corner on the male form. So we can see there that we've got a direct match between those two. Now we've got a direct match, but of course these letters are essentially the same size. Therefore, if I was to take the male form and try and push it into the female pocket, it's going to bind together because they are exactly the same size. So in essence, what we need to do is to make an allowance either on the male or the female. Now typically you would generate the male form first, therefore you would have a physical letter generated, and then you would go ahead and generate the female pocket and just maybe modify the allowance on that female so that you had the correct fit when pushing the male form into that pocket. Okay, so let's assume that that is the way we're going to work here, that we will make the allowances with the female side because we've already generated the male, we have it in our hand, we can lean over onto the machine and push it on and check the fit. Okay, so I'm going to open up the female inlay now. Okay, and notice at the moment that we are cutting to the vector. Okay, so on this form about halfway down we can see pocket allowance. Now what I'm going to do is I'm going to add on an extra 20 thou here, which means we're going to overcut this pocket clear by an extra 20 thou either side. So with that I'm now going to calculate that, and immediately with the solid preview you can see the little bit of extra material being removed, okay, on all edges to allow us a little bit more clearance to push the sort of male letter E into the female pocket. Okay, and that was all done through applying a positive allowance into the female inlay toolpath. Okay, so before we move on and take a look at the sort of step male with a whole female type inlay, we're just going to save this part. So I'm going to do File, Save As, and we're going to save this as the straight inlay. So just so we can refer to this at a later point, I'm going to come across now and just delete out all my toolpaths. So I'll delete all and reset the preview and just close that out, and then just be faced with the 2D view that we've got on the screen. Okay, so we'll come back to the Inlay Toolpath, and we're going to be now moving down to look at the stepped format. So essentially we will create the same profile as the letter from the front, but it will have a sort of recessed step at the back, and then we'll combine that with the female, which has a straight through hole in it, and therefore the letter, the male letter, mounts from behind the actual pocket and sits against the back face of the female by virtue of the step. So we'll select the left hand vector first and pick stepped as being the male inlay type. We have a very similar form, but obviously some extra features that we'll get to in a minute. Now our start depth will be 0 again. Our cut depth we need to have still as the material thickness, which will be Z equals, which will be 1/2 inch. We'll select our tool, which will be our 1/4 inch end mill. And then we'll come down to where we specify the step. Now this step will be outside of the sort of profile of the letter. So our step depth, in this case, I'm going to go down by 0.375. So the step at the back will be just 0.125. So actually the height of our letter will be 0.375. So 0.375. Our step width, that's how wide we want the step. In this case, I'm just going to keep that as say 200 thou. I'm not going to apply an allowance to the male. We'll do that to the female. And then we can come down and just specify the name. So in this case, it will be a stepped male inlay. So we'll calculate that now. We can see that toolpath generated. And if we just play that, we will see the result of what we get. We still have the same letter as we had with the previous example, but we have this additional step that's been added, bearing on the mind that this letter will be pushed through a hole in the female to create the sort of male to female form. Okay, so we're going to come back now to look at the female letter. So we're going to select our right hand vector and come across to the same toolpath type, inlay, and we're going to select the hole option for the female. Now the cutting depth, we're going to be specifying that start depth is 0. Our cut depth will be all the way through here. So this will be once again Z equals to give us our full depth, which will be 1/2 inch. Our tool will be the same, which will be our 1/4 inch end mill. So we'll select that now. We can just specify whether it's climb or conventional, but importantly here, the allowance offset. We need to make sure that we apply a little extra so that when we try and push in the male from the back side of the female, it will not sort of bind too tightly and just neatly fall into place. So I'm going to apply that as being 20 thou, but this is something that you may want to play with, bearing on the mind the dynamics of your machine, the type of tools you're using, the material, etc., and any finish you may want to apply to that material. Okay, so now we're going to come down and just specify that as the hole inlay. So I'm happy there with that, and calculate, and we can just play that now, and we can see that we have our inlay. So we're just going to get rid of the material there for the essentially the center of the female. So this male form on the left hand side will push in from the back side of the female. So once again, this will be the face that will be mating against these edges here. But of course, one thing that we have noticed here is that the height of our letter is just 0.375 here. So that's the height there, because we still have essentially a 0.125 inch step there. And on the right hand side, our female is a full 1/2 inch. So essentially, if we do push this in from the back side of the female, we will be sitting down from the top by 0.125 of an inch. So in reality, we would not make these out of both of the same sort of material. We would have the female being created from the 1/2 inch, and the male will be created from a thicker material to include obviously the step that's needed when we push it in from the back side of the female. Okay. We've created this out of the same piece, but in reality these would be out of two different material thicknesses. But that just shows the two different types. We looked at really the straight cut inlay, where it was just pushed into a female pocket. But in this case, maybe for instance we're creating an aluminium sign and we want to create an acrylic letter that we push in from the back side that could be backlit, in which case here I'm doing a hole inlay for the female, and we're using the stepped inlay for the male that's just going to push in. But once again, we need to make sure that we were cutting the male from an increased size of material that would include the step, to make sure that it's flush fitting the male with the top of the female when we push it together. Okay, so with this now, I'm just going to close out of the form now, and what we need to remember from this particular tutorial is to make sure that we also apply an allowance, because the allowance will be the key aspect to whether we can get these two items to mate together and get a nice fit, rather than trying to overly push or hammer in the male into the female in order to get it to fit. And of course, making sure that we use the same tool on both forms. Okay, so with that, this comes to the end of this tutorial, but what I'll do to finish with, I'll just save that now. So we'll do a file save as, and this will be a stepped inlay. So I'm just going to change the straight to a stepped, and we'll save that now, and we can refer to that at a later point.